Hey, in this tutorial we're looking at section 10.3, which is of measures of centre and spread. Okay, so our expected value, or our mean value, or our average value, hey, to find that what we need to do is create a distribution table. Okay, and what we do is we multiply our x values by the probability associated with those x values, okay, and then add your answers together. So what it is we have a formula, it's e of x equals x1 times the probability that x equals x1 plus x2 times the probability that x equals x2 all the way up to xn times the probability that x equals xn. Okay, we've got some properties for expected values. So the expected value of a times x plus b equals the expected value of ax plus the expected value of b, okay, which is equal to a times the expected value of x plus b. So if we're finding the expected value of just a constant, it's just the constant itself. Okay. If we had the expected value of x plus y, that's equal to the expected value of x plus the expected value of y. Okay. The expected value of x squared does not equal the expected value of x all squared, and this is really important. Okay, it's going to come up in just a second. Okay, but that one's one that we've got to keep in our memory. Okay, and you'll see why right here. Because with our variance and our standard deviation, okay, the measure of spread of a random variable distribution tells us how the data is dispersed. Okay, and so we use our variance and our standard deviation for that. Okay, so the variance is VRA of x, okay, and that's equal to, this is sigma squared, okay, which is equal to the expected value of x squared minus the expected value of x all squared. Now, that's why we said these aren't the same things, because if they were, it just equals 0 all the time. Now sigma here, that's equal to our standard deviation, and we can also write that as SDX, okay, which equals sigma, which is the square root of our variance. Okay, we've got an identity for our variance as well, which is the variance of AX plus B is equal to A squared times the variance of X. Okay, the B isn't really important. So we'll get stuck into a couple of worked examples. So worked example 4, hey, find the expected value of the random variable with the following distribution table. Okay, so we've got our distribution table here, so x can be 10, 20, 30 or 40. Our probabilities that x equal x are 0.42, 0.34, 0.16, 0.07 and 0.01. And we're asked to find our expected value. Okay, so all we do is we go e of x equals 10 times 0.42, so that times that, plus 20 times 0.34, plus 30 times 0.16, plus 40 times 0.07, plus 50 times 0.01. Okay, when we do the arithmetic, we find that our expected value is equal to 19.1. Okay, 19.1 is what we'd expect to get if we conducted this trial, or whatever it is that's representing multiple times. We'd expect to get 19.1. Okay, worked example 5. Okay, given that we've got this probability distribution table, which is 5 minus d on 5 minus d, okay, has a probability of 7 on 20, and 3 minus d has a probability of 9 on 20, minus d has a probability of 1 on 10, and 3 plus d has a probability of 1 on 10, okay, and we know our expected value is equal to 1. Okay, we need to find the value of d and the expected value of 5x plus 3. So what we need to do is run through our expected value. So our e of x equals 5 minus d times 7 on 20 plus 3 minus d times 9 on 20 plus minus d times 1 on 10 plus 3 plus d times 1 on 10. Okay, is what we need for there. Hey, so if we expand out our brackets, okay, we find that e of x is equal to 35 on 20 minus 7d on 20 okay, plus 27 on 20 minus 9, so 9d on 20, okay, minus 2d on 20, plus 6 on 20, okay, plus 2d on 20. That's expanding out our brackets and having all our denominators as 20. Now we know our expected value is equal to 1. Okay, and when we add these together and everything, we end up getting 68 minus 16d on 20. So you can say, well, 20 equals 68 minus 16d, okay, which means minus 48 equals minus 16d. So d equals, d equals 3. Okay, so we know our d equals 3. Okay, so what we want to do now, okay, is we're looking at finding e of 5x plus 3. Okay, well, when we look at that, that's really the same as 5 times e of x, okay, plus e of 3. Okay, well, our expected value of x is equal to 1, so that's 5 times 1. Our expected value of a constant is just our constant. Okay, so it's going to equal 8. Okay, that's all we need to do for that one. Okay, we'll keep moving on. Okay, we've got work example 6. Okay, so for work example 6, we're told a discrete random variable x has the following probability distribution. So we can see x can take on the values of 1 to 5 and have probability of 0.15, 0.25, 0.3, 0.2, 0.1. We're asked to find the expected value of x, the variance of x, and the standard deviation. Okay, so the easiest thing to do with this is start off with our e of x. That's equal to 1 times 0.15 plus 2 times 0.25 plus 3 times 0.3 plus 4 times 0.2 plus 5 times 0.1. Okay, when we do that, we end up, and we run through and do our arithmetic, we find the expected value is 2.85. Okay, the next part we need to do, okay, is we need to find e of x squared. Okay, because we need that to find our variance. Okay, so this time what we do is we square our x values before timesing them by our probability. So we say we've got 1 squared times 0.15 plus 2 squared times 0.25 plus 3 squared times 0.3 plus 4 squared times 0.2 plus 5 squared times 0.1. And when we do that, we find that we get 9.55. Okay, running through the arithmetic, which isn't too complicated. Now our variance of x is equal to our e of x squared minus our e of x squared. So that means our e of x squared is 9.55, and we're going to take away 2.85 squared. Okay, when we do that, we find our variance is equal to 1.4225. Okay, and we know our standard deviation of x is equal to the square root of our variance of x, okay, which means it's the square root of 1.4225. So we find our standard deviation is 1.1948. Okay, and that's all there is for that worked example. So if you really set these things up well, and you just do your expected value, your e of x squared, your variance and your standard deviation in a nice, logical, well set out manner, you won't have any difficulties with these questions. Okay, now I've got one more worked example to do here, okay, which is not in the textbook, it's another one that I've used in the past. We need to find k, okay, and then we need to find the expected value. Okay, so we know that x can be 1, 2, 3, 4 or 5. The probability that x equals 1 is 2k minus 1 on 13. For x equaling 2, it's k squared minus 3 on 13. For 3, it's 6k minus 7 on 13. At 4, it's k squared minus 1 on 13. And for 5, it's just 1 on 13. Okay, so how would we go about trying to find k in this one? Well, we need to remember that the sum of our probabilities equals 1. So what we need to do is say then, well, 2k minus 1 on 13 plus k squared minus 3 on 13 plus 6k minus 7 on 13 plus k squared minus 1 on 13 plus 1 on 13 is equal to 1. Okay, so we can say then, well, 2k minus 1 plus k squared minus 3 plus 6k minus 7 plus k squared minus 1 plus 1 is equal to 13. Okay, we're going to say we've got k squared plus k squared, well that gives us 2k squared. Okay, and then we've got 2k plus 6k is 8k. We've got minus 1, minus 3 gives us minus 4, minus 7 gives us minus 11, minus 1 gives us minus 12, plus 1 gives us minus 11, equals 13. Now if we take our 13 away, we can say we've got 2k squared plus 4k minus 24 equals 0. Okay, so we can divide by 2 and say k squared plus 2k minus 12 equals 0. Okay, we would need to factorise that expression now as well. Okay, so we need to go, well, what can we use here to get this to work for us? Well, we might need to go for our 2 squared, our minus 2 plus or minus the square root of our 2 squared, take 4 times 1 times minus 12 over 2, we get our minus 2 plus or minus the square root of 4, 8 plus 48 on 2, so minus 2 plus or minus square root of 52, 8 on 2. Okay, so we're getting there. So what we can say is we can bring 4 out as a common factor here. Out of our 52. So we can make it minus 2 plus or minus 2 root 13 on 2. Which means we get minus 1 plus or minus the square root of 13. Okay, so we need to think about this a little bit though, because we can't take minus 1 minus 13, okay, because we're going to be less than 0. Okay, and if we're less than 0, if we're a negative, well, you can see here this one would end up being a negative and that one would end up being a negative. We can't have negative probabilities. So then k has to equal minus 1 plus root 13 to work. Okay, have to be minus 1 plus root 13. Okay, so we've been able to find our k value through that. Okay, so look, that was just an extra little worked example. Okay, look, I really don't think you'll have too many troubles with these questions. I think you'll find them pretty straightforward.